Welcome to Saucy Math. This is going to be the first in a series of videos that I do on factoring. Now, factoring is a useful tool in mathematics. It's not so useful in your everyday life, but it is useful in mathematics, and it's used a lot when you're trying to solve equations. So when you're going through algebra, pre-calculus, calculus, even beyond that, depending on how high you want to soar on your mathematical wings. That sounded like a really weird thing to say just now. But it is a useful tool that you'll use throughout mathematics and also in some science classes as well if you take physics classes and stuff like that. So this first video on factoring is going to be about the most basic type of factoring, which is factoring by using a common factor. All right, so I'm just going to go through a few examples and kind of show you how to factor by finding a common factor. So when we're factoring, basically what we want to do when a problem says, factor this expression, the first thing you need to know is what exactly does that mean that they want me to factor this expression. It means to take this expression, like this first one we have here, 6x to the fourth minus 12x to the third plus 21x squared, and rewrite that expression as a multiplication problem, as two or more quantities being multiplied together, which, if you would multiply it out, you would end up with this expression that we start with. Right, so that is what factoring is all about. It's rewriting our expression as multiplication. So when you're looking for a common factor, and no matter what factoring method you're going to use for the problem you're looking at, you should always start by trying to find a common factor. Because if your expression has a common factor, it's going to make any other method that you use easier to do. All right, so 6x to the fourth minus 12x to the third plus 21x squared. We want to see, do those three terms have anything in common? And there's two parts to it. There's the numbers and there's the variables. So if we just kind of take one part at a time, the numbers, we have 6, negative 12, and 21. So what number can divide evenly into 6, negative 12, and 21? And we want to find the biggest number that can do that. All right, so the biggest number that divides into all three of those is the number 3. Right? 3 will divide evenly into 6, negative 12, and 21. So my common factor is at least going to involve a 3. But I also have variables here. So now we need to look at the variables as well and see if there's anything that the variables have in common. All right, so I have an x to the fourth, an x to the third, and an x squared. So what all those variables have in common, right, the biggest thing that I could kind of divide away from all those is an x squared. And when it comes to variables, the trick is when you're trying to figure out, well, what's the common factor of all these different variables? If all your terms have, in this case, an x raised to a power, your common factor is going to be the x raised to the smallest power. Right, so our powers on the x are a 4, a 3, and a 2. 2 is the smallest one, so my common factor is going to involve the x squared. All right, so my common factor is 3x squared, and then I'm going to put a parentheses, and then inside the parentheses is going to be whatever I have left over when I divide each one of these terms by a 3x squared. Right, now some of you could probably do this in your head. If you can't, or if you're just learning how to do it, a way to maybe make it a little bit easier is to take each one of those terms and actually write them over that common factor of 3x squared. Right, it kind of just helps you, if you simplify this, what you end up with is going to be what you put in the parentheses. Right, so if we have 6x to the fourth and we divide away 3x squared, well, 6 divided by 3 is going to give us a 2. And then the x to the fourth over x squared, if you remember the rules of exponents, you subtract the exponents. 4 minus 2 is going to give us 2. So that first term inside the parentheses is going to be a 2x squared. If we multiply this common factor, 3x squared times the 2x squared, that would give us 6x to the fourth power that we started with out there. And then we do the same thing for the other two terms. All right, so we have then negative 12 over 3. 12 divided by 3 is 4. And since it's negative 12 divided by 3 is going to be a minus 4. And then we have x to the third over x squared. All right, once again, subtract the exponents. 3 minus 2 is 1, so we have x to the first power. And then we do the same thing for the last term. We have 21x squared over 3x squared. 21 divided by 3 is going to be positive 7, so it's plus 7. And the x squared over x squared, right, those actually cancel out, so our last term inside the parentheses is just a plus 7. Right, and that would be our factoring of this original expression. Right, so 6x to the fourth minus 12x to the third plus 21x squared equals 3x squared times 2x squared minus 4x plus 7. All right, that's our factoring by finding a common factor. If you were to distribute this and multiply this 3x squared back into the parentheses, you should get exactly what you started with over here. So you can always do that as a way to like double check after you get your answer. If you multiply that all the way back through, you should end up with the same thing. And if you do, that means you probably did everything right, unless you kind of made a mistake twice and it just happened to work out, but that's pretty rare that that would happen. All right, so that's our first example with a common factor. All right, the next one we'll look at, similar type thing. All right, we have a polynomial here, 4x to the 5th minus 12x plus 20. We want to factor this by trying to find a common factor. So once again, we have numbers and we have variables. So do one at a time. Look at the numbers. We have 4, negative 12, and 20. Is there any number besides 1 that divides into all three of those evenly? There is, and that number is 4. All right, so my common factor is going to involve a 4. Now we also have the x's here, so let's take a look at those. We have an x to the 5th, an x, but this plus 20 at the end does not have an x involved, right? So in this case, our common factor is not going to involve the variable x because all three of our terms do not have the x, right? We can only use it as a common factor if all three of our terms involve that factor, right? So since that last one doesn't have an x, we can't pull out a factor of x. So in this case, our common factor is just going to be a 4. All right, so if we do this kind of like we did that last one, if we think about dividing all those terms just by a 4, well, 4x to the 5th divided by 4 is going to be 1x to the 5th, which is just x to the 5th power. Minus 12x over 4 is going to be minus 3x. And then plus 20 divided by 4 is going to be plus 5. All right, so we have now factored that expression, 4x to the 5th minus 12x plus 20 equals 4 times x to the 5th minus 3x plus 5. And once again, if you distribute that 4 into the parentheses, you should end up with the exact same expression that we started with. And if you don't, it means you screwed up somewhere, and you can go back and try to figure out what you did wrong. All right, last example we'll look at, we got negative 7x to the 4th y squared plus 21x y to the 4th. All right, so once again, we want to try to look for a common factor here. This time we have numbers, but also we have two variables. So it's a little bit more complicated than those last ones, but we still approach it the same way. Right, the numbers we have are negative 7 and 21. The number that divides evenly into both of those is going to be a 7. All right, then we have x's. We have an x to the 4th power and an x to the 1st power over here. Remember, when we're dealing with the exponents and the variables, we take the variable with the smallest exponent as our common factor. And x to the 1st is smaller than x to the 4th. So in this case, I can only pull out that x to the 4th power. Then I have the y's. I have a y squared in the first term. I have a y to the 4th in the second term. The smallest one is the y squared, so that's the one that's going to be part of my common factor. Right, so my common factor here is going to be 7x y squared. And if I approach this like those other ones, if I think about dividing my two original terms by that common factor, 7x y squared, we can see what we end up with inside our parentheses. All right, so negative 7 divided by 7 is going to be a negative 1, so I'm going to have a negative here. I have x to the 4th over x, right, so it's a 4 minus a 1, so that's going to be x to the 3rd power. Then I have y squared over y squared. Since those exponents are the same, those just kind of cancel out. Right, so I end up with just a negative x to the 3rd in that first term inside the parentheses. Then for my second term, I have a positive 21 divided by 7, so that's going to be plus 3. I have x over x, right, so I'm taking away that x, so that completely cancels out. I have y to the 4th over y squared, right, so again, subtract those exponents, that's going to leave me with a y to the 2nd power. And once again, if we distribute this 7xy squared into the parentheses, it should give us exactly the expression that we had over here. And if you check that out, you'll see that it does actually do that, which means that we did this problem correctly. All right, so that's a few examples of factoring by using a common factor. Make sure you check out my other videos on factoring. There's a few other methods for factoring that get a little bit more complicated. So make sure you take a look at those because they are going to be pretty awesome.